Evening, I'll be covering a little bit on my 8 position tool turret. I have added an additional tool number 1 or master tool position sensor and implemented a macro to allow the tool turret to be initialized to tool number 1 position every time I hit the reset button. How did I go about this is I have my tool turret. I've already made the back plate as well as the front plate to cover all the mechanical and electrical parts. Okay, I will show you what I have implemented. Okay, so let me rotate the tool turret. Okay, this is the rear portion of the tool turret. Okay, as you can see, there is a wheel attached to the turret shaft, in which it has 8 teeth machined in place, and there is a slot cut over here. Okay, now the slot will be used to trigger this optical interrupter, and this optical interrupter is wired in such a way that it is the homing switch of axis A of the CNC lathe. Okay, and then the remainder 8 tooth is used to count tool 1 up to tool 8, but at the moment I have decided not to implement it because I don't really need it for my application. I've just added it for future if I do need to monitor the other tools. Okay, but at the moment the most important thing is I need to monitor tool number 1, which is the master tool. So upon reset of the CNC lathe via Mark III, the x-axis will home first, followed by the z-axis, and lastly followed by the a-axis, which is the tool turret. Okay, to demonstrate this, okay, now you can see that from the earlier position, you can see that the tool turret it's physically at tool number 6. Okay, it's physically at tool number 6, but if you see Mark III tool number, it's tool number 5. So clearly there is a mismatch between the physical location and the indicated position by Mark III. Now, in order for us to rectify that, we need to re-initialize the tool turret to tool number 1, which is our master tool, and we need to synchronize both the mechanical and the indicated value. Okay, so how do I implement that? Is through an initialization macro. Now I'll show you later how I have implemented it and how I've configured it in such a way. Okay, now observe machine coordinates. If I hit the reset button, the machine goes into reset, or upon booting up, it is in reset state where the reset button is blinking. Now once I've hit the reset button again, it will home the x-axis followed by the z-axis and rotate the tool turret to tool number 1. So if you see here, the tool number has changed to 1, and the mechanical location of the tool is also indicated by tool number 1. Therefore, it has synchronized the tool turret to tool number 1, and it is ready for the CAM program. Okay, to demonstrate it, if I were to move the tool somewhere else, say, let's say I move it to T0606, tool number 6. Observe, the tool changing capability is still maintained. So now we are at tool number 6 mechanically, as well as the indicator shows that tool number 6. Now, say I want to reinitialize to tool number 1, I just have to hit the reset button once. It goes into reset and then hit it again. Now, if you observe, x-axis is homed, z-axis is homed, and then the tool turret is homed again, and finally it goes back to tool number 1 and changing the state of the tool number to number 1. So again, observe, let me just randomly send the turret somewhere else. T0404, tool number 4. Okay, I'm telling it to turn to tool number 4. Okay, say I switch off Mark III. Yes, I reopen or reload Mark III. Okay, I select the device. Okay, observe, driver successfully initialized. I am at, the indicator shows tool number 4 and the turret also shows tool number 4. Okay, say I want to reinitialize to tool number 1, all I have to do is hit the reset button. Okay, again x-axis is homed, z-axis is homed, and then the tool turret is rotate to tool position 1 or the master tool. Okay, so if I were to move it to any other tool, say T0808, it will move to tool number 8 accordingly. No missing tools or mismatch of tools. As long as I hit the reset button, it will reset x-axis, z-axis, followed by the a-axis. Okay, back to tool number 1. Okay, now if you observe, let me rotate the turret again. Okay, I have to be careful. Okay, if you can see here, there are two sets of wires. One is for the tool turret sensor, which indicates tool number 1, and the other is for the stepper motor. Okay, so now we are back to tool number 1. Let me shift it to tool number 7. Just randomly moving it. Observe the wheel. Okay, so this slot here, let me zoom in a bit. Okay, if you observe, let me bring this over. Okay, here it is. If you observe, this slot indicates tool number 1 position. Okay, and this other teeth here indicates the other tool, but at the moment I'm only implemented the sensor over here and not over here. This is for future if I want to use it, but at the moment I really do not need to do so. Okay, the sensor is, all this stuff here in yellow is actually hot glue. I'm using it as some form of epoxy to cover up the electronics. Now it's a very simple electronic. It's just the sensor. There will be a ground wire, a power supply wire, and a 1 kilo ohm resistor to supply current to the infrared diode, and then the transistor, which is used to trigger the on or off position in Mark III, sends one output through one wire back to the breakout board as an input signal. So if the slot lines up with the sensor here, it will indicate an active state. Currently I set as an active low. So if you check out your diagnostic, okay, let me just show you that. Let me just put it over here. Okay, let me move to the diagnostic screen. Okay, observe, I quit, go to diagnostic. Okay, let me move it a little bit over here. Okay, observe home A, which is over here. Okay, so now I shall press the reset button. It will reset x-axis followed by z-axis followed by A. Now observe the turret wheel and the light home on. Can you see the yellow light flicker for a while? Now when it detects the home position, it will stop the turret. Okay, it will reset or set the A axis to be 0 machine coordinate, 0 degrees machine coordinate, and it will back off the homing switch just a few degrees, such a way to change the state. So it goes back, it goes to active A home will light up, followed by deactivate the home, and then it rests at the tool number 1 position. So if you go back here, you can see here it's back to tool number 1, and then I have also coded it in such a way that it shows all axis and tool turret initialized in the message here. Okay, the next part is how I have implemented the macro. Okay, first of all, in order for you to implement the macro, you have to go to options, Visual Basic Script Editor, open the window, file, type in your VB codes here, but I have already created the code. Let me just show you. I'll just open. Okay, the macro is stored under C Mark 3 macros, Mark 3 turn. Okay, now M3, M4, M5, M6, let me zoom in a bit. Okay, these are default macros. Okay, M6 start macro is used for the tool changing, and M1000 is the custom macro which I added in. So this is how the macro works. Okay, the first part, your subroutine main and your end sub, this just to tell it is the beginning and the end. It's just a Visual Basic scripting line. Okay, so the first portion, RefCombination 1, will tell Mark 3 to home the x-axis. 1 is for x-axis, while it's moving is just a flag. So any of the axis moves, the flag here will indicate 1. That's all. I'm not using the flag, but it's just I put it in for future. Okay, if I do need it. And then once I've done that, I will move x-axis 2 millimeters away from the home switch, which is at 0 machine coordinate, 0 on x machine coordinate G53. Okay, the reason is I want to ensure that I am a certain distance away from the home switch, so it doesn't kind of have a false trigger. The reason is my home switch and my limit switch for the x-axis is the same. Okay, then I home the z-axis, which indicated here by RefCombination 4, which 4 is for the z-axis, same again the flag, and then move z away from the home switch by 2 millimeter. Means it goes towards the spindle direction. 2 millimeter, that means 2 millimeter in the negative direction. And then finally I perform x, perform z, and I home the A axis, which is indicated by by number 8. Sorry, by number 8. Okay, now homing RefCombination, you can search this in the Mark 3 programming manual. It's all listed there. It's a general item. Okay, then once I've done that, I will move the A axis by 0.1 millimeter in the opposite direction of rotation to ensure that I will lock the tool turret properly into position without creating any form of movement. This is needed because the design of the turret is using a ratchet and pawl system. So in order for me to guarantee that I have locked the pawl and the ratchet in the correct position, I move backwards to push it a little bit, nudge it into place. Now, the value 0.1 is just a value that I have found to work. I can put more, but it will create a kind of buzzing noise when the stepper motor pushes against pushes the pawl against the end stops of the tool turret, which creates a kind of noise which you probably do not like, and it will cause damage in the future. So the idea is just to nudge it slightly, so the value can be from 0.1 to about 0.3. It's about degrees. You can't go more than that. Okay, so the value is it can vary, depends on your design, but it should just return the turret in the opposite direction just slightly, just to keep that pressure on the ratchet and pawl to maintain that position. Okay, once it's done, once all the axis is initiated, the physical tool turret will show tool number 1. Therefore, you need to update the tool indicator. Hang on, let me just change the window. Okay, here, this is the tool indicator. This tool indicator needs to be updated with respect to the initialize master tool. So this particular command here, set current tool to 1, will write to the screen DRO 1. Therefore, the screen will show tool number 1 as well as the physical turret will be at position number 1. And then finally, just send out a message, all axis and tool turret initialized. That's all. You can put any message you want, but I decided to put that. Okay, now once you've done, you saved it. Okay, and then what you do is you just have to close this. Okay, I've already saved it, so I'll just click no. Okay, after you have saved it into the macro folder, you need to go to config, you need to go general config. Okay, what you need to do, you need to go here. Okay, you need to select here, tick here, use string at all resets. Means by ticking it here, for every time you reset, hang on, let me go back a bit. Every time you hit the reset button, it will invoke all the string in this box here. Now, the string in the box is the I set the default feed rate to be 100. I set this with G80, and at the same time I set the macro called M1000. M1000 is the initialization macro. So okay, once I've done that, just click OK. The rest of the settings is the same as previously, nothing new. Of course, make sure you save the settings and you're ready. So